a biological point of view, but from the point of view of materials scientists, this is interesting that the material can repeatedly do this cycle. All right, so this is where we are. We are trying to take advantage of this phenomenon now. The spore gets bigger and then it shrinks. Let's make larger materials and try to see if we can harness this property. You can put a solution that has lots of spores in it, let it dry. Spores will assemble themselves on the surface. You have to be careful when making this sample. But in the end, this layer will change its shape. We are putting spores in a rubber, and you can see now we're blowing dry air and then humid air, and we alternate that. This very thin layer of spores bend the thick, nearly 500 times thicker rubber sheet back and forth in response to changing humidity. And at first I thought, okay, well, let's demonstrate some useful application to this. We made this larger sheet, and then there's a magnet and a coil. A magnet and a coil, if you rotate the magnet, you can generate electricity. So we made that rubber sheet generate electricity just to see that spores can produce something useful. The amount of it is actually very little, but we're improving. Then this is what made me think, okay, you change humidity and then you get some electricity, right? But in the world that we live in, humidity doesn't change so rapidly. It changes on a daily and seasonal time scale. That won't be that much power. But we have lots of open water surfaces, and maybe we can harness that because moisture is actually going into the air. And if you think about it, trees already harness that. Water wants to evaporate, and trees use that to lift something up. It requires energy, right? We have elevators, and we spend energy to lift something up to the 8th floor, and trees use evaporation to lift all that water up there. And we can make a device that can perhaps harness the same phenomena that trees use and capture energy. So this is one way of doing it. You can make a material out of spores. This is still hypothetical at this stage. That will stay on the surface of water, and we will have a shutter mechanism on the top and the bottom. And if the bottom shutters are open, it will let moisture in. This material will expand. And then that movement will open the top shutters. If you design this carefully, you can do that. The top shutter is open now. It can dry into the air, and it would like to shrink. It will go back to the first state, and then it will cycle again, and you will have something that will move back and forth if you put this on the surface of water. And if you have another device next to it which can generate electricity from movement, then you will be producing electricity. How can we make a material that can move horizontally on the surface? That big rubber wasn't so useful because it's moving in and out of that surface. It changes because of curvature. But we thought we can have these plastic tapes, and we can coat them in a careful pattern, like a dashed line. We put spores, and we leave a gap, and then put more. Once they dry out, they're like a paste that dries out, and then you flip it, you put more spores, but now you align them carefully, so gaps on the other side, now you put spores there. In the end, the material has this wavy shape, and it gets longer when it's humid. So here's a photo of it. As you increase the humidity, it grows. We put a tube around it, and then we're now flowing, we're testing it. We flow dry air and humid air, and then it goes back and forth. It's quite dramatic in terms of movement. And in this case, we also repeated this more than 1 million cycles, and they're doing fine. So that's an indication that if you make a device, it might work for a very long time. Okay, one of them is not so powerful, actually. You can have many of them in parallel. It's a lot of work to put these little droplets on the surface, so you can imagine this is a lot of patience to get it to work. And in the end, there's a bigger, there's a plastic box around this. It's transparent. We are flowing air again with dry and humid, make this movement. Now we have that, it's like a carpet that elongates and shortens. Now we can put this on the surface of water. Let's do one more stage. So we're building this step by step. we have this material. It's stretched from one end to the other, and what I'm doing now is I need to change humidity of that environment. What I can do is I can actually breathe towards it. My breath would make it moist, and then as it dissipates, it will dry out again. So I'm actually sitting somewhere here. This is my breath moving this material. It's pulling and pushing. So this is part of the device functional right now, but we haven't made the entire thing. And now let's put the shutters. We made it a little simpler than the initial cartoon, but now we're pouring water. That yellow carpet is in here. These are the shutters. They will move. So what happens here is when moisture from that water fills the inside of this box, the material expands and it opens the shutters. But when shutters are open, the laboratory air is dry, so moisture escapes, and then the carpet shrinks, and then close the shutters. Now it can fill up again, and this cycle continues. Where is the energy coming from? It's actually heat in the environment. As long as you have access to dry air and heat and water, then this flow is going to happen, and you can actually capture some energy from that process. Before wrapping this up, I want to show you another interesting device. So when we had that engine, we thought, okay, if we have this engine, why don't we make a car? Right, it actually proved quite difficult because that's a single piston device, which is very difficult to create rotational motion. So we thought, okay, let's design another one that would rotate. How this would rotate? We put these plastic films, spore-coated films, around a circle. The blue ones are also little plastic weights. What happens is it's inserted halfway into this chamber. The chamber is covered with wet paper. So it's humid inside the chamber and it's dry outside. So the curvature of these plastic tapes are a little different on the inside and outside. There's an imbalance of this circle because center of mass is not exactly at the rotation axis. So let's see how this will respond. So as you insert it, this imbalance causes it to rotate. The ones that go outside, they dry out, so they change their shape quickly, and the ones that go in, they get hydrated, they change their shape quickly. It keeps on going. It's going to stop when all the water evaporates, because then it will be dry inside and outside. It will equilibrate. Now, going back to this car, right? We are ambitious. We put this on wheels. It's not so powerful, right? But it might be the first of its kind, and that's good enough for now. But eventually it might. Yeah. Mm-hmm.